Hello students, let us start with third part of hydrocarbon. We are going to deal with physical properties of alkanes. The physical properties of alkanes such as boiling point, melting point, density and solubility depends upon the intermolecular forces of attraction. Since alkanes are almost non-polar molecules because of the covalent nature of carbon single bond carbon and carbon single bond hydrogen bonds and very little difference of electronegativity between carbon and hydrogen atoms. Therefore, these intermolecular force of attraction are of van der Waals type, which mainly depend upon the shape and hence the structure of the molecule. The magnitude of these force of attraction depend upon the surface area of contact between adjacent molecules. Greater the surface area, stronger are the van der Waals force of attraction. Let us discuss the first property, boiling points. Amongst the straight chain alkanes, the first 4 members are gases, the next 13 are liquids, and the higher members are colorless waxy solids. The boiling points of straight chain alkanes increases fairly regularly with increase in their molecular mass. The difference in boiling point is, however, greater for the lower homologous than for the higher homologous. This regular increase in the boiling points of straight chain alkanes with increase in the carbon content is due to a corresponding increase in the molecular size and hence the surface area of the molecule. As a result, the magnitude of van der Waals force of attraction goes up and hence the boiling point increases accordingly. So this is very important point to solve a lot of concept based questions in your back exercise. Also, this concept is applied in class 12th also during organic chemistry. Amongst isomeric alkanes, the branch chain isomer has invariably the lower boiling point than the corresponding normal alkane and means normal. This is due to the reason that with branching, the shape of molecule tends to approach that of a sphere. As a result, the surface area of the branched isomer decreases. Due to lesser surface area of these molecules, the van der Waals forces of attraction operating between their molecules become comparatively weaker and hence lesser amount of energy is required to overcome them. As a result, the boiling point of branch chain isomers are lower than those of the corresponding normal alkanes. Greater the branching, lower is the boiling point. For example, normal pentane, it's shown on the screen, isopentane, neopentane. As you are moving towards the branching, the boiling point is going to decrease. Melting point. The melting point of alkanes also increases with increase in carbon content. But the variation is not regular. Alkanes with even number of carbon atoms have higher melting points than those with odd number of carbon atoms. The melting point of a substance depends not only upon the size and shape of the molecules but also upon how closely the molecules are packed in the crystal lattice. But due to sp3 hybridization in alkanes, any two bonds of a carbon atom make an angle of 109 degree 28 minutes with one another. As a result, in normal alkanes, the carbon atoms are arranged in a zigzag chain rather than a straight chain. Therefore, in normal alkenes containing an even number of carbon atoms, the two terminal methyl groups lie on opposite sides of zigzag chain. In case of normal alkenes having odd number of carbon atoms, the two terminal methyl groups will lie on the same side of zigzag chain. Thus, it is clear that normal alkanes with even number of carbon atoms are more symmetrical than those containing odd number of carbon atoms and hence pack closely in the crystal lattice. In other words, van der Waals force of attraction are much stronger in normal alkanes having even number of carbon atoms. Pay attention here the word for even number of carbon atoms than those having odd number of carbon atoms. Therefore, normal alkanes with even number of carbon atoms have much higher melting points than the next lower normal alkanes with odd number of carbon atoms. Solubility. Alkanes which are predominantly non-polar are insoluble in polar solvents such as water, alcohol, etc. but are highly soluble in non-polar solvents such as petroleum, ether, benzene, carbon tetrachloride, etc. Gases are mixtures of higher alkanes and hence are non-polar and hydrophobic in nature. Similarly, petrol is a mixture of lower alkenes. Thus, both petrol and gases are non-polar. It is because of this reason that petrol is used for dry cleaning of clothes to remove grease stains. Density. The densities of alkanes increases with increase in the molecular masses. All alkanes are lighter than water.